Cheers and welcome to your NumPy journey. Alrighty then, just really quickly before we start the tutorial, for those of you who want to support the channel and join, you can do this by clicking the subscribe button right here and enable the bell button as well. So now that's out the way, let's get on with the tutorial. In this video, we explore how to randomize and sort arrays in Python using the NumPy library. We cover several techniques like shuffling, permutation, random choice, and generating random integers to manipulate arrays. You'll learn how to apply these methods to reorder and randomize data for different use cases. Finally, we'll demonstrate how to sort the randomized arrays for easy analysis. Let's dive in and see how you can efficiently randomize and sort arrays in Python. Here we import the NumPy library and gives it the alias np. NumPy is a library used for numerical computing and particularly for handling arrays and performing various mathematical operations. Here we initialize 5 variables: 2-dimension array, 1-dimension array, shuffle, 1-dimension array, permutation, 1-dimension array choice, and 1-dimension array random integer, and sets their values to 0. These variables will store different manipulations of the 2-dimension array through the code. Here we create one-dimension array with integers from 0 to 9, inclusive, and reshape this array into 1 by 10 array, a single row with 10 columns. The result array is assigned to one-dimension array. Shuffle method randomly shuffles the elements of the array in place, modifies it directly. After this line, the order of the element will be randomized. Here we print the shuffled version of the array to the console. Flatten method is applied to two-dimension array, again converting it into a one-dimension array and storing the result in one-dimension array permutation. Permutation array creates a new array with the same elements but in a randomly permuted order. The result is reassigned to one-dimension array permutation. Here we print permuted version to the console. Flatten method is applied again to two-dimension array, converting it to one-dimension array. The flattened array is assigned to a one-dimension array choice. The choice method randomly selects element from one-dimension array choice without replacement. The size ensures that 10 elements are selected. Here we randomly select elements from a one-dimension array choice without replacement. The size ensures that 10 elements are selected, the same number as in the original array. The replace attribute ensures no repetition of elements. The result is stored back in one-dimension array choice. Here we print the array generated using the choice method to the console. Here we generate a 1 by 10 array of random integers between 0 to 9 inclusive. The result is assigned to one-dimension array random. Flatten converts one-dimension array random, which is two-dimension array, into a one-dimension array. The result is stored back in one-dimension array random. Here we print the random integer array to the console. Then we print a separator line to make the output more visually clear. Here we sort the shuffle array in ascending order. The sorted result is assigned to the variable shuffle. Here we sort the shuffled array in ascending order. The sorted result is assigned to the variable shuffle. Here we sort the permuted array in ascending order. The result is sorted and assigned to variable permutation. Here we sort the array which was generated using the choice method in ascending order. The sorted result is assigned to the variable choice. Here we sort the random integer array in ascending order. The sorted result is assigned to the variable radInt. Here we print the sorted version of the shuffle array to the console. Here we print the sorted version of permuted array to the console. Here we print the sorted version of the choice array to the console. Here we print the sorted version of the random integer array to the console. And here, by pushing this button, you can run the code. Finally, I just wanted to show you where to get all of the course files. So it's this repo right here on my GitHub, Python NumPy series 1. The link to this repo going to be down below in the description, and if you want to see the code for a specific lesson, you have to select that lesson from the branch drop down right here. For example, to see lesson 1 code, click on this branch and you're going to see all the code right here. If you want to download lesson 1, then you go to the code and download the zip. Or you can clone this repo to your local computer, whichever you are more comfortable with. In the next episode, we are working on array indexing. If you enjoyed this series, my friends, please don't forget to share, subscribe, and like the videos. That really means a lot, and I'm going to see you in the next.